Awesome. Well, we have an exciting session, I think, for you today. Super pleased to see all of you turn out. My name is Stephen Jones. Most people call me Steve. I'm the general manager of our SAP business at AWS. We've been doing a very fun project, a meaty project with SAP over the last couple of years. And I'm joined today by Stefan and Matt. I'll let them introduce themselves just a little bit.
Okay, wonderful. Thanks a lot, Steve, and great to see you all. My name is Stefan Beule. I'm from SAP, and I'm actually heading all database engineering, which also is including HANA and HANA Cloud and all other database assets as well. And hand it over to Matt to introduce him.
Great, thank you. Hello, everyone. I'm Matt Zenas. I run our global SAP HANA and database product management and strategy team. So I'm actually in Stefan's HANA and database development organization.
Right.
Fantastic. All right, folks. Yeah. All right, so a few things of what we're going to cover today, but really the goal is to help you, as many of you are probably also underway or considering taking a journey of maybe porting some of your most critical workloads to Graviton as well. How many of you have heard of Graviton? Of course. And so the goal here is to actually share some lessons learned from the project along the way, and so that is the goal. We're going to take some questions at the end. So be kind of thinking of those as we're going along, and we'll give you some time for that as well. I won't spend a lot of time on that, but this project is built on the back of a very long partnership that we have with SAP. I'm sure many of you have heard how at AWS we like to start with customer requirements and then work backwards. Our relationship and the work that we've done with SAP is no different, right? So very early on into this thing we like to call cloud now, customers were asking us, what do you think about running SAP in the cloud, right? When we started thinking about this, it was very early on. And so we started to partner with SAP on just what would it actually take to run a mission critical application like SAP in the public cloud, right? And along the way, we learned a lot. And early customers began to adopt the platform. And all of those learnings went right back into, research, development, and improving the product. And, midway through this journey, SAP introduced a very high-performant database called HANA. It's an in-memory database. And, of course, this requires special compute instances. I think at the time, the biggest compute instance that we had from a memory perspective, I think it had maybe a 1/4 terabyte of RAM, right? And we were considering at the time, well, how much memory would a customer actually need? Maybe 1, never 2. Could never be that big, right? But we took a purposeful decision at that time to actually start building custom hardware with lots of memory to support this in-memory database, because this is where SAP customers were telling us they wanted to go. If you fast forward to today, earlier this week, we just announced the generation 2 of our high memory instances with up to 32 terabytes of RAM. I mean, who would have thought? My son, who is a gamer, likes to tell me that he's got a very big desktop, right, that's got 16 gig of RAM. And I turn around and tell him that we have servers that have 32 terabytes in them. But anyway, you can imagine there's a lot of work that goes onto engineering systems like this, very complex. And along the way, we built higher level services and been working with SAP, and they've been on a journey of their own, and they're going to tell you a little bit about what that's been like here in just a minute. But over the due course of time, we got together on this journey towards Graviton. And a little bit about Graviton. I don't want to spend a lot of time on this, but if you look across the portfolio of AWS instances, of course, the largest set of instance types have supported Intel from the very beginning, right? We slowly started to introduce instances with AMD processors, which are also very performant. And then customers started asking us, have you guys ever considered building your own chips? Really pushing us on price performance. And of course, the partners that we work with very closely, told us how complex it is, and it is absolutely complex. But we continue to listen to customers and the reasons why. And so we started to partner with a little-known company called Annapurna Labs, based out of Israel. This was back in the 2016, 2017 timeframe. And back then, we were actually trying to figure out how to take all of the typically expensive work that happens in the hypervisor layer and offload it into hardware. Because we were seeing, I would say, a not insignificant tax or virtualization tax. And so we wanted to be able to provide all of the compute power and memory capacity to customers and not have to reserve a bunch of that for hypervisor processing or usage. And so we spun up this joint partnership with Annapurna. We built these cards, and then we thought to ourselves, these were based on ARM, by the way, Graviton, they were early Graviton chips. And we said, we think this is something we really ought to do. And so we set to work. It took us quite a long time. But over the last, as you can see here, 3 years, we've been quickly iterating on these Graviton chips and instances. You can see in 2018, we released our first Graviton instance with a completely customized ARM processor for AWS. We do all the design and work with the manufacturers, obviously, and then put them in our systems. And then we got to Graviton 3, and we started having conversations with SAP. But I think the question is why? Why is this so compelling? Well, so we generally, when we compare Graviton 3 to their counterpart instance in the same generation, we're seeing upwards of 25% price performance improvement. The best part, though, is that we're saving a ton of energy. And if you can think about, just imagine all of the data centers and servers and racks and what it takes to actually power the cloud, right? There's a lot of power there, and we want to be responsible. And as we continue to grow, we generally at Amazon have a commitment and a pledge to reduce and to get to carbon neutrality. And so Graviton is helping us get there. A lot of our key internal services, and I'll talk a little bit more about our managed services, have actually gone to Graviton. So I mentioned a little bit about some of the Nitro cards, right? Those are the hardware cards that had the early Graviton processes in there. In these Graviton instances, there's an entire system that is almost entirely hardware. So obviously it includes the Graviton processor, there's an onboard security chip, there's the cards I talked about, and then we have a very, very lightweight hypervisor. And what I can say is that in benchmarks, and we've done SAP benchmarks, and we've benchmarked performance against bare metal and these virtualized Nitro instances, we generally see performance differences that are really negligible. So let's get into the meat, I guess, of the conversation, which is around what does it actually take to move an application to ARM, essentially, right? And as you can imagine, there are all different types of applications out there, and the complexity is different depending on what you're thinking about, right? So as I mentioned internally, we've done a lot of work to take our managed services already and port those engines, the software that powers them, to be able to leverage Graviton, right? So that's essentially not a lot of effort for you. It's mostly a console selection, right? And then for serverless, again, that's pretty easy. We make that available for you to actually use as well. When you start getting into custom code that you've actually built over the years, we find that Java, Python code is relatively easier. You'll find a lot of open source packages. You can just essentially, instead of having to recompile everything, you can kind of pull in the most recent updates, and you'll have support for ARM. But then we get into more involved, right? C++, C, database engines, and that requires some work. And so I'm going to turn it over to Stefan to tell you how they approached the workload at SAP, and you'll find, I think it was not a real simple task.
Not really, no. Thank you so much, Steve. So talking about more involved tasks and C++ code and what that means in terms of coding, we will talk a little more in the next couple of slides and say next half an hour or so, what that really meant, so to give you that insight. Before we go there, maybe a little introduction what SAP does and what also SAP HANA Cloud does. Who of you hasn't heard about SAP so far? Okay, awesome. In a few very numbers, SAP is a market-leading company around all enterprise application software, right? Across core ERP and surrounding processes across many industries. It's meanwhile in the ballpark of 106,000 employees globally, worldwide, spread around 100 development locations. And as you can see as well, with a very large partner ecosystem that are driving that into the market as well and extending the processes as well. If we look at it from a portfolio point of view, at the core of the enterprise application software systems is the ERP, specifically also the cloud ERP, which is S/4HANA, which is basically taking care of all of the core ERP processes and the fundamentals like financials and others. And that is, on the one side, extended into multiple different industries and their specifics, and at the same time surrounded by a bunch of applications that are line of business specific, be that HR related or spend management and business networks, supply chains and these kind of things. Also customer relationship management, right? And for quite a while, there is also an ongoing effort to infuse AI into all of these processes and the mission critical things that are relevant for our customers as well. And also recently, with all the movement on the AI space and the business AI activities also at SAP, there's more things that happen in terms of automation and infusing more and more intelligence. And at the bottom, you see the business technology platform, which is basically our technology portfolio, which is infusing basically all of the technology assets and needs that we use for our own applications, but that also our customers and partner use to build their application and their extensions in the SAP ecosystem as well, and on the business technology platform. To give you maybe a little idea of what that means in terms of overall market presence and impact, the overall SAP customer base generates 87% of the global commerce worldwide, which is basically touching something like $46 trillion, right? So which means a lot of the world economy is actually running and powered through SAP systems and applications, right? And basically all of the big global companies out there have SAP footprint in some shape or form, right? Now zooming into the business technology platform piece, there is a couple of elements in there, and I'll read through all of that. But just to give you an idea of, that is basically the whole reach of technology that are needed from an enterprise application point of view, starting from application development and application servers, right, and development environments and all of that, through automation, integration, data and analytics into the AI pieces that are basically all of the ingredients that we and our customers and partners need at the end to build enterprise software, right? And as we talk about SAP HANA Cloud and the databases, we are actually looking at the data and analytics pillar as part of the business technology platform, right? So talking about SAP HANA Cloud, let me start with a bit of a history on how that happened and what that journey was over the last 13 plus years. And Steve already shared about it. There's an own kind of history on what happened. It goes back to 2010 when SAP HANA launched the first time. And obviously, there were a couple of years before in our development labs that where all of the heavy lifting and the work to get the product ready to launch. And it was back in the days the first in-memory data platform on the market, right? And ever since, there was an evolution about adding more and more functionalities, going from more analytical workloads to more transactional workloads and everything in between in terms of hybrid transaction and analytics processing, adding more and more functionalities in not only relational things, but also other engines. I see a couple of steps on that journey. And the last kind of major new change was then basically bringing all of these technology and assets into the cloud, right? Which is then using AWS as a hyperscaler and the infrastructure underneath. But also from a database point of view, there were a lot of changes that we did in terms of transforming the database into a cloud-native managed service that we provide. From a HANA footprint perspective, I was talking about the overall touch on global economy from an SAP portfolio point of view. Maybe what is interesting is that if you look at it through the lens of the database, HANA and HANA Cloud in particular, that is in the ballpark of 73,000 global customers worldwide that are running directly or indirectly on an SAP HANA Cloud database, right? And actually, this is mission-critical systems and processes that are actually running on these systems, right? And Steve talked about it earlier, right? I mean, some of these databases can become very big, right? Not only a single node, but also in a scale-out way. To look a little more deeper into what happens behind the scenes of HANA Cloud, right? And there will be more details coming in subsequent slides. On the applications that use HANA and HANA Cloud as a database, it's basically the entire portfolio of enterprise application needs, right? From analytical applications, like also our own analytics portfolio, into transactional application, into everything that our customers and partners build on the business technology platform for their own purposes, right? Be that standalone applications, be that extensions, or whatever the scenario is, right? And obviously the spectrum in between, right? And specifically in latest information days, we see a lot of things happening specifically in new scenarios as well that our partners and customers build around intelligent data applications that make use of the power and functionality, right? Talking about that one, HANA Cloud is not only a relational database, as you might assume, but it's in fact a multi-model database, right? Which means it has a relational engine in memory columnar, but also it comes with a spatial engine, a graph engine, a document store. And some of you might have seen the latest announcements just a couple of weeks ago when we announced the new vector engine, which is specifically relevant in the current ongoing dynamics around generative AI and large language models. There's also special functionalities built in terms of advanced analytics, which means own machine learning and predictive algorithms that are part of the database and the data platform that basically can be used to run scenarios on top of that, but also more information modeling, semantical elements for kind of analytical processing at the end of the day, including multidimensional things. And on the tiering side, there is, if you look at HANA Cloud, multiple tiers in terms of storage, where you can keep your hot and relevant data in memory for high-speed processing. But you have also other tiers down to object stores and data lakes where you can keep your larger amounts of data connected through these layers, right? Now, why did we start the journey 2 years ago to port HANA Cloud to Graviton, to AWS Graviton, right? And actually, there were 3 kind of main motivators behind that. The first one is about what is the innovation potential that we see behind that, right? If we see the history of SAP HANA, like the many years that I showed you on the prior slide, as you can imagine, there is a lot of work in the code base to really optimize as a system-level software that it is for really performance to the largest possible extent, right? Very closely to the hardware and the infrastructure that we see there, right? And the question was, what is it that we can innovate close on that, hardware-software interface, then also if it comes to ARM-based architectures, specifically with AWS Graviton, right? The second element, specifically, as that matters a lot for cloud services, is around price performance. So what is it that we can achieve there in terms, reducing cost on the one side, but also improving on the performance on the other side, right? How does that metric play out, right? As a key quality on that side. And last but not least, and Steve talked about it in terms of energy efficiency, that's also a concern that we at SAP have, right? What is it that we can do to reduce the impact of our technologies onto the environment, right? So sustainability and energy efficiency was also a key argument why that movement onto AWS Graviton was a key project that we were driving forward in the last 2 years. Now, to give you a bit more insights in what exactly happened during that journey and what we did in terms of that porting and the results that we have seen, let me hand it over to Matt to run you through that one.
Great. Thanks, Stefan. I appreciate it. So actually, Stefan and Steve did a wonderful job teeing up and showing you the what and why of SAP HANA Cloud, as well as AWS Graviton. That was a great way to kind of set the stage. And what I'm going to be sharing with you over the next several slides is the how, the where, and the when in terms of porting SAP HANA Cloud to AWS Graviton. And specifically, what I'll be getting into are some of the details around the work streams, how we kind of organized the project, some of the challenges that we had, both technically and organizationally. We'll get into the project timelines, how we've gone through the optimization process to optimize SAP HANA Cloud on AWS Graviton, and then also, and more importantly, to show you the results of porting SAP HANA Cloud to AWS Graviton. And also, what were some of the lessons learned that we have? So, to be sure, I hope it was clear when Stefan mentioned it, SAP HANA Cloud is a highly engineered database as a service for very extreme workloads. And so when you talk about taking everything that he had mentioned, all those different pieces of HANA Cloud, and you want to re-platform that essentially, that's a non-trivial task. There's a lot of moving parts to do that. Now, that doesn't mean that a migration or a porting to AWS Graviton is difficult. It's just that from a HANA perspective and a HANA Cloud perspective, there were some unique challenges that we knew going into this that we just wanted to share with you. First is, as Stefan mentioned, HANA Cloud is a fully managed, cloud-native, multi-tier, multi-cloud database as a service, right? It's very high-performing, does transactions and analytics, and to be even more precise, it is the de facto database as a service for SAP applications and services. So, and that's really big, which means it's running really important workloads. The other thing, too, that we'll get into more details about is that SAP HANA Cloud has a lot of different microservices, or a lot of microservices, just a sheer volume of them. So those needed to be dealt with as we made this port to AWS Graviton. And as usual, there's not always technical issues that you have to deal with. There's sometimes organizational ones, right? In this case, when you have a mission-critical enterprise database as a service like SAP HANA Cloud, there's a lot of interdependencies within the organization. There's development teams, and there's various development teams. there's operational teams, there's infrastructure teams, there's security teams, you can imagine, right? And you have to coordinate and communicate with all of them. And so there's a lot of lessons learned there. Now, in terms of adopting AWS Graviton for SAP HANA Cloud, what we're showing here are kind of what I would say are the main work streams, the key pillars of the project. And in terms of, from a product and service perspective, there's really actually three key parts to it that we'll go through. And then we'll get into some of the testing aspects. But when you break down the whole project and take kind of a 10,000-foot view of what we were doing, these were the main work streams. The first is our continuous integration and delivery build pipelines. Those needed to be ported to AWS Graviton. So this included adapting the build systems to consume Graviton virtual machines. It included building multi-arc images as well. Also, then there's the microservices, and we'll spend more time in additional detail on this in particular, what we had to do, because I had mentioned before just about the sheer volume that we had. But this was about adapting ARM-ready workload schedulers, things along those lines, adapting the microservices to the AWS Graviton platform, and also switching virtual machine pools. And then you have the database engine itself in terms of the database, the SAP HANA Cloud database engine. So this required doing command set adaptations, engine adaptations to trip structure, and also general performance improvements. And we'll talk more about some of the optimizations and the approach that we took. And then, of course, covering all of this for all these big rock items, the continuous integration and delivery pipelines, the microservices and the database containers, this also then required the testing, right? So this required enabling the test platform to consider the Graviton infrastructure. This also considered the full end-to-end multi-arc testing and also performance testing. And just to put it in perspective, there were thousands of unit and integration tests, both end-to-end, to cover all the different scenarios. Now, this is a very, very high-level view of the SAP HANA Cloud architecture, but I wanted to share it with you to kind of show a couple pieces here. First is around the building blocks that when we were moving SAP HANA Cloud and all the components to the AWS Graviton infrastructure, what those building blocks were, and also the vast and variousness of the different microservices. So at its base, of course, you have the infrastructure as a service, the ARM-based AWS Graviton infrastructure, and then building upon that, the Gartner-managed Kubernetes services. If you're not familiar with Gartner, Gartner is an SAP Kubernetes project, an open source project that we contribute to. And then, of course, we have the microservices that are on this, that are basically via the SAP Common Services infrastructure. That's how we deploy it. And then on top of all this, the SAP HANA Cloud database container containing the code line for the database. What we show over on the right-hand side over here are just kind of a sampling of the various microservices that we have that manage the SAP HANA Cloud service. So these are things like security, monitoring, backup, HA, DR, infrastructure, elasticity, things like that. These are just a few examples of some of the ones that we had and that we had to look at moving to the AWS Graviton infrastructure. Now, when you look at a project timeline, this is obviously a very, very high-level view. I think the way I would really just try to describe it simply is that this is a journey, not a destination, right? There's multiple phases to this. We talked about timelines and when we got kicked off, but essentially, as we're showing here, we kicked this off in early 2022, what we'll call the ARM foundation phase. So this was like, getting the infrastructure ready, getting the teams up, things along those lines. And only about 6 months later, in late Q3 2022, we actually had our first initial port of the SAP HANA Cloud database, that database engine that we talked about, to the Graviton infrastructure. Then about 6 months later, we had some selected microservices, those HANA Cloud microservices, moved over on the Graviton infrastructure, as well as those cloud CI/CD services as well that we moved over. Then, late last quarter of this year, we actually had our very first HANA Cloud workloads running in the AWS Graviton infrastructure, which was great. And we made an announcement about this a few weeks ago, and you probably saw some announcements, obviously, at the keynotes this week. Going forward between now and, as you can see here, mid-2025, this is an exercise of refinement, of improvement, of optimization, things along those lines, and continuing to work together with AWS to do that. So let's touch a little bit more about the microservices, because I've mentioned that a few times now, and just to put things in perspective. So this is kind of the overview of the different aspects of the microservices that we were dealing with, and how we collaborated and migrated and containerized them. Essentially, what we were dealing with to start with was about 250 microservices that were part of SAP HANA Cloud. And the services that were mandatory for Graviton support needed to be migrated. So what we did is we actually, with the SAP developed microservices, we jointly with AWS ProServe migrated those over to the AWS Graviton infrastructure. And the good news is, for many of the open source services, there are ARM versions that are available. In terms of a migration perspective, the enablement of the services on the Graviton 3 nodes was done via what I'll call a smooth migration approach, not an abrupt approach from the Intel to the Graviton chips. And we did this over time. And basically what that meant is that since there was no hard migration, this helped prevent instance downtime and things along those lines. And from a containerization perspective, we had to do the Gartner adaptation. So again, Gartner is the Kubernetes project that's part of SAP's Kubernetes project. So adaptations had to be performed. This included working closely with the SAP HANA Cloud engineering teams and the SAP Gartner teams to do this. But this included the enablement of Gartner Shoot clusters, the release of ARM-based binaries, and support for SAP's hardened container for Linux distribution, the Gartner Linux. So, what did it do? What does it look like from a performance perspective? This is actually the current state of performance that we can share with you today. So what we're showing here is the results of a benchmark of SAP HANA Cloud running on a Graviton 3 system versus an Intel-based Ice Lake system. This was based on similar system sizes of about 64 virtual CPUs and 256 gigabytes of memory. Now in the chart, what you see here on the x-axis are basically from 0 to about 10,000 the different test scenarios that were run. And along the y-axis is the percentage improvement of running that particular query, that performance test, versus the Ice Lake. So above the x-axis is positive, means that we saw, you can see they're up to 50%, some are even up getting close to 150%. And then below that, did not outperform that. But here's what we found, is that there was actually a very big difference between the performance and the workload that we were running. So that was what we saw, is like the workload class made a big difference. So in this case, the analytic workloads ran much better in Graviton, whereas the transactional ones did not. And of course, those are the areas that we need to focus on jointly with AWS to work on that, for those potential improvements. So what is our approach for optimizing SAP HANA Cloud on Graviton? So what we're laying out here is kind of the approach that we're taking in terms of the the different segments and how we're doing it. First is just from an overall optimization perspective. Obviously, we're looking at various things that we can do, not just one thing. Some of this includes code vectorization, like Neon and scalable vector extensions, compiler upgrades, compiler options, local code changes, things along those lines. And in terms of just the identification of areas of optimization, we're using the HANA performance regression tests, both via scenario or on a case-by-case basis, and we're doing these regression tests in the HANA continuous integration, continuous development, delivery pipelines, excuse me. And from an analysis perspective, the analysis has been done with internal and external tools and monitoring data, call stack profiling, down to the very detailed micro-architectural level using the ARM statistical profiling extension. And of course, working very closely and collaborating with the AWS Annapurna labs to further optimize HANA Cloud for both current and upcoming Graviton processor generations. So, what were our key learnings and takeaways? And what worked well and where did we struggle? So first of all, from a project perspective, the way we approached this was a scaled Scrum approach to coordinate multiple teams, like I mentioned. There was a lot of different teams that we had to engage and work on this project. And so within each of these teams, sometimes we had permanent and sometimes we had temporary team members that were part of that helped work on the burn down for the Scrums. But what this did require, it was a lot of coordination across these teams, a lot of communication. And speaking of communication, there was a lot of communication, of course, with executives across SAP and AWS. So this was a great forum to bring up either showstoppers or blockers or issues and get them out of the way, very soon. So that was really critical and worked really well. Also, what worked well was the adaptation of the architecture agnostic Docker images, and also the fact that we were able to adapt around 150 microservices from the Intel-based platform to the AWS Graviton infrastructure. And then, of course, enabling all the required continuous integration and delivery to achieve essentially the same quality standard that we had on the x86 platform. So where did we struggle? Again, not so much from a technology perspective, just more of an approach. First of all, our initial port was done very early on, prior to even having those build pipelines available. So because of that, there was some decreasing developer efficiency because we had really aggressive timelines. We actually ported a lot of the aspects, a lot of the database and things like that before a lot of that had been done. I think you probably saw that on the timeline where we did the initial port, and about 6 months later, then we had the CI/CD pipelines, we had the microservices and things like that. So that caused us a bit of some struggling with some of the developer efficiency. Then also, there was effort in provisioning some external instances. Really, that was more of an internal issue in terms of when a developer needed an instance to do some troubleshooting and analysis to get access to that instance. SAP has very, very stringent security and compliance regulations, and so that was more of an internal process thing that we needed to work out so they could get access to that. So at the end of the day, what are the results achieved? Basically, it's fantastic news. 35% better price performance for those analytical workloads we talked about. A 45% estimated reduction in the carbon footprint for SAP HANA Cloud. And so what I can tell you is from an SAP development perspective that the folks that were working on this project are really excited and proud of what they delivered and what they were able to do in that amount of time. Obviously, there's more work to do, and we're really looking forward to continuing to work with AWS on continuing to optimize and refine, and also innovate SAP HANA Cloud on the AWS Graviton infrastructure. With that, I think I'll turn it back over to Steve.
Awesome. Thanks, Matt.
Yeah.
So I don't know how many of you actually saw earlier this week. We continue to obviously iterate on the Graviton design. And a lot of the learnings that, I would say many of the learnings that we learned from the joint collaborative work here, which you can tell was complex, have gone into, I would say, Graviton 4. Specific things like, well, actually, let's get a little bit into it, right? So Graviton 4 instances, we released a preview of our first version, which is the RAG instance, actually carry up to 30% better performance. That's largely driven by the fact that they have 3 times as many processors. And we're also delivering up to 3x the amount of RAM as well. Now, both Stefan and Matt talked a little bit about performance of analytical workloads, right? And some challenges with transactional workloads. We're pretty excited about what we think will happen with Graviton 4, especially for transactional workloads, given a lot of advancements in the prefetch algorithms and what's actually on the chip itself. So I don't know if you want to say anything about maybe some early work.
I can, yes. So we had a chance in the last couple of days and few weeks, as it's also shown here, right? I mean, it's in preview already. So we had a chance to look at Graviton 4 as well, and run some of the benchmarks that you've seen on Matt, what you shared on the performance test, right? And there is very much excitement as well about what we have seen there, right? So we are seeing not exactly the 30%, but really close to it, also on the analytical side in terms of improvements, Graviton 3 to Graviton 4, right? And as you just said, right, I mean, there's even more things that we see for the transactional workloads, which is also very encouraging. So very good step forward on that side as well, and looking forward to that one from a HANA Cloud perspective. And there's the one thing is the one is the performance side, maybe to comment about, but the other one in terms of also the growing memory size and capacity that Graviton 4 will bring us is obviously another kind of very interesting innovation and advancement, right? Because Steve, you said it in the beginning, right? I mean, there's for HANA specifically, as it is in a memory database, quite a big demand in terms of memory capacity for certain kind of scenarios and workloads. So seeing like more memory and bigger instances coming is for sure something that is totally exciting.
Yeah, how many of you remember at the beginning I said we started early on in the journey of supporting HANA with instances of 1/4 terabyte of RAM? And in this case, Graviton 3, I think we were working up into system sizes of 1/2 terabyte. You can imagine with the R instances, we're going to get up to 1.5 terabytes of RAM. And then we have a plan with Graviton 4 to actually move into the X family, which many, if you know where X is, there's multi-terabyte there. So it's not 32 terabytes of RAM. I will be clear about this at the moment, but we love it when customers push us, and we like to push boundaries as well. And it's really it's partnerships and key projects like this that help us push boundaries and really prove what can be done as well as optimize, right? To keep learning, and then everybody benefits from it. I want to just highlight a couple things that are helpful to get started. We put a lot of documentation together on how to get started, and where to get help, and how to actually sequence potentially a complex project like this. We've also developed and released, I believe it was just a couple months ago, what we call a porting assistant. This is freely available. You can download it in GitHub. You can actually work directly with your own source code. We're not going to store anything. This is freely available for you to use. It's open source. And it'll actually help do some simulations and work as you try to understand how best to take your code bases and move them through to ARM and Graviton. It does support C, C++, I'm just reading here Fortran, because I can't remember all of the languages off the top of my head, Java, Go. It's really, really meant to cover a broad spectrum of things. And I know this slide is kind of funny because we're right at the end of reInvent, but this is mainly for if you want to learn more about all of the other things that we're doing together with SAP and what other customers are doing. All of these sessions, have been presented, I think, for the most part, but can be watched later. And finally, there's always things that you can do, self-paced labs, certification, trainings of that nature. And I think at this point, I would love to open it up for questions.